Okay, greetings everyone. This is Karen Jahanian from KMJ Consulting. We're providing technical support to the I-95 Corridor Coalition. You are on the Mobility as a Service webinar, Understanding the Concept, Current Status, and Role of Data. It is the top of the hour, so as promised, we will begin. We have an exciting session for you today, and let's get started. So some housekeeping items before we begin. Everyone, hopefully if you are not online yet, you can dial in and everyone will be in listen-only mode. If you require operator assistance, please press *0 and they can respond to any of your questions. If you have a technical issue that is causing you difficulties on the web or audio, please call Justin Ferry at 484-557-7009, and he will help you. This webinar is being recorded, and the presentations will be posted to the I-95 Corridor Coalition website, and you will receive a link to those presentations sometime following this broadcast. As I mentioned earlier, you're on listen only, and therefore all questions will be made through the chat box. So please post your questions there. We will be monitoring them, and we will answer them at the end of each respective presentation. And if we end up with a lot of questions, which I imagine is possible, I'm sure the speakers will respond to those questions either immediately following their presentation in written form in the chat box. And if there are any questions that remain unanswered, we will have a record of the chat box and the speakers can get back to you afterwards. And the full record will be on the Coalition's website. So with that, I would like to introduce Denise Marco from the I-95 Corridor Coalition. She is the TSMO Director, and we'll take it from here. Thank you, Denise.
Thank you, Karen. Hopefully everybody can hear me okay. Today, as Karen mentioned, we're going to hear from two people who are familiar with what I call the ever-changing world of MaaS, Mobility as a Service, and also talking a little bit about mobility on demand, even though that's not in the title. I think Carol will talk about the difference between those two. A few months ago, one of our members had asked if the coalition could put together a webinar about these two topics, MaaS and MOD, as there's like a growing discussion about the strategies, what exactly they are, who's doing what, what's the state of data that's being used or collected, and just basically how can we best proceed. So you're going to hear from these two folks who are very familiar with this topic. Carol's going to speak to the concept of what actually is the difference between MaaS and MOD, as well as discuss some case studies or pilot studies that are taking place in the country. And then she's going to be followed by Joe, who will talk about the data. So in planning the webinar, we had asked a few folks within the corridor to submit some questions to better shape the discussion. And the speakers, they have looked at them, and they're going to try to integrate some of them as best they can into their talk today. But however, if you still have questions, as Karen mentioned, please use the chat box. We will be monitoring it, looking at it, answering either online or verbally after each of the presentations. So the agenda today, welcome and introductions. Then Carol's going to come up with her titled presentation is MaaS. Uh-oh. Can somebody be on mute? There we go. Understanding the concept and current status. Joe Castiglione is going to come in with MaaS, PNCs, and data. There will be a question and answer session after that, and then a wrap-up. So that's our agenda. Coalition-sponsored event. We have 225 registered today with 19 states. DOTs, Turnpike authorities, MPOs, federal agencies, universities, vendors, and consultants. So we have quite a diverse group that's going to hear them speak. As you know, our famous slide here about the coalition. Basically, we're 16 states plus DC, all located in the corridor. if you look at those metrics, the second largest economy in the world, or 37% of our population along the corridor, some news I can bring to the table today is that we are currently looking to expand the region, as well as looking at updating these metrics so that we can bring you some new metrics on the value of the corridor. That's going to be forthcoming shortly. So with that being said, let me introduce these guys to you. First on the left, Carol Schweiger. Carol, for those of you who don't know Carol, she's got nearly 40 years of experience and is nationally and actually internationally recognized in transportation technology consulting. Her range, her depth of expertise in areas including technical strategies for public agencies or public transit technology or traveler information strategies. She works all over the globe, a lot with ITS World Congress. She's provided over, I think, 60 transportation agencies with technical assistance. She co-developed and instructed transit ITS training courses for the National Transit Institute, NTI. And she also works with USDOT in professional capacity building or PCB courses. She's authored numerous books, numerous articles, I should say. She's delivered multiple presentations. So she really is a force in this world and is very, very well-versed in what you're going to hear about today. Joe Castiglione is the Deputy Director for Technology, Data, and Analytics out of the San Francisco Transportation Authority. He's been developing, he's been refining, applying advanced transportation like supply and demand models for 20 years. He's led the development of the original SF CHAMP. It's an activity-based travel model. It was the first activity-based model used extensively in an application in the U.S. And subsequently, he's led efforts to do other travel demand simulations with dynamic traffic assignment models. Wow. So prior to joining the San Francisco Transportation Authority, he worked as a consultant, but he is now the Deputy Director. So with that being said, let me welcome Carol and Joe. And Carol, if I can turn this over to you. We welcome your presentation.
Thank you so much, Denise. And welcome to everyone who's on the webinar today. And this is always a really exciting topic for me, and one that has sort of taken over the world, and a lot of us are talking about it and further developing it in various parts of the world, which is something that I will talk a little bit about. So let me give you an idea of what I'm going to cover today. Talk a little bit about what really is mobility as a service. Sort of a lot of terms get thrown around, and as Denise mentioned, there's a bit of a difference between mobility as a service and mobility on demand. So I'll talk about that. I want to give you 4 sort of cases of how mobility as a service is being developed in the U.S. and then give you some food for thought about sort of the development timeline for mobility as a service. Talk about, throughout my whole presentation, I'll be talking about the importance of data, and Joe is going to give us a great dive into that aspect of mobility as a service. And then I'll leave you with some more food for thought there at the end about how the needs of a city or a region should actually be balanced with traveler needs and private sector needs as well. So let's kind of jump right into this. Now, I'm guessing if any of you on the webinar have been following mobility as a service, you may have seen this diagram before. It actually comes out of Finland. It is the graphic representation of what mobility as a service is, which is an integrated transportation network by which you can access any of the services through a one-stop shop. And you can see in the middle of the slide, the customer is really the key here. And the customer has access to all of these various kinds of assets that are shown on the left and the right-hand side of the diagram. Now, I want to focus on the circle. And the reason why I circled them is this is really what we're talking about today. First of all, in the middle there is a circle around data. Joe is going to give us a really comprehensive view of data, of how important the data is, and various strategies for obtaining the data and analyzing it. And really the data underlies mobility as a service. Without the data, a traveler doesn't know what options they have to travel. So it's really key. And if you look on the left-hand side of the chart, I've circled something that is called logistics. One thing in mobility as a service that we don't spend a lot of time talking about, but it's critical, is the component of goods delivery. It's not just about delivering people to where they need to go. It's actually also about delivering packages and freight where they need to go, because they're a significant part of the transportation system overall. And typically when we talk about mobility as a service, we kind of skip over that. So I wanted to highlight that. I also wanted to talk a little bit about how this is multimodal. This is not just public transportation services and bike sharing services and car sharing. It involves the highway significantly because people are still traveling. And indeed, they may still be traveling on highway. So in the lower right-hand corner, we have real-time traffic management and the infrastructure, mostly the highway infrastructure, and those are significant components of mobility as a service that we don't talk about enough. And I think this is the prime time to bring that to bear as we talk through our examples of mobility as a service. And then the rest of this diagram really talks to connecting people to services like healthcare, education, entertainment, and having personalized services. So when they go to look for their alternatives to travel from point A to point B, the services that are returned to them are those that they would want to travel with. So the service is very personalized. Two other things I want to mention, because I probably won't mention them again. There are very few real deployments of mobility as a service around the world. And we are just barely scratching the surface in knowing whether mobility as a service should be provided by a private company, by a public entity, or by maybe a partnership. And the second thing is, we are not yet familiar with how this will look if there are competing mobility as a service system. So those are things that people are studying today. So let's move into just talking about the difference between mobility as a service and mobility on demand. Let me start with mobility on demand. So really, it's a system whereby a trip or the movement of goods and services can be made on demand. So these services are available to me. They are accessible if I need certain kinds of accessibility, and it's within a connected transportation system. And so they're available on demand rather than me jumping in my single occupant vehicle and traveling from point A to point B. So it's a rather broad concept. I think about mobility as a service as one of the tools that really facilitates mobility on demand. And when you learn about some of the mobility as a service systems that are being developed around the country, you can see that they're really a tool in providing mobility on demand. So that's really the difference between the two. And on this slide, I talk about some other services. People tend to confuse mobility as a service with all of the new services like ride sourcing, which some people also call ride hailing, and the other sharing modes and microtransit. And then we have a whole contingent of folks that work on transportation demand management, and that is different from mobility as a service. It's really to get commuters out of their single occupant vehicle. And then mobility management is a rather broad term, but it really has sort of grown into providing alternatives for people who actually can't drive. So this slide is just meant to show you that we have a more complex transportation and mobility ecosystem than we ever have had in the past. And so we're constantly adding new services to that ecosystem, and we want to make them available to travelers, but we don't want them to have to individually access each of these services. So mobility as a service is kind of that one-stop shop. I get all of my alternatives, and I can pay for my trip only once for the whole trip. So let's launch into some examples, some concrete examples of what's being developed in the U.S. LA Metro is one of the largest transit agencies in the country, and fortunately, they have been working very hard on developing mobility as a service, and the platform that they are using is actually their fare collection system and their fare card, which is called TAP. And you can see in this slide that not only do you use TAP to access all of the transit services provided by LA Metro, but you also can now access a bike share. You will eventually be able to pay for your tolls with your TAP card, so that brings in the highway side, and you can potentially in the future pay for electric vehicle car sharing with this same TAP card. So that's how they are building mobility as a service. They will be adding more and more mobility services to this picture. So when they speak about the benefits of building a mobility as a service system, they have a variety of different benefits. But I want to focus on just one of them on this slide, which I think relates a little more to the audience, and that's incentivizing behavior. If you're looking at, for example, a bad air day and you want to give people options as to how they can get from point A to point B without just driving there, this is a way of doing that, where you can provide those alternatives. Also, offering rewards and discounts is really taking hold, where LA Metro can now see more and more people utilizing services other than just jumping in their car and driving. So that part of that aspect of the program, they're constantly building And I think those are very important aspects of what they're doing in LA. Let's move to Dallas, Texas. Dallas has a pretty significant mobility as a service framework that they've actually been working on for the last 5 years. And the way they envision it, it really has 4 key pieces to it. And again, I've used the circles to highlight a couple of things that we want to focus on here. So in the upper left-hand corner of their charter, all of the mobility services, whether they are provided by Dallas Area Rapid Transit, which is developing this mobility as a service system. So it's all of the services, again, on my sort of mobility ecosystem slide. And then in the lower left is really the applications that people will be using to access mobility as a service. In the upper right-hand corner, and I think this is something that they've really mastered, they're still working on it, but they've done a really good job, is the public-private partnership agreements with the service providers. And I know Joe is going to go into this a little bit, but underlying this is the data that is necessary from all of the partners to tell the traveler whether there are any issues they're going to encounter during their trip. So there's a data component there. One of them I circled right below where it says customer. And then in the lower right-hand corner, once again, we don't often speak about the highway side, but they are bringing in traffic management and some other services like parking, automated vehicles, for example. That's down here, and looking at the connected traveler eventually. So you can ask, well, if they started doing this in 2014, why aren't they there yet? And it's because they have taken a very logical and stepwise approach to utilizing one of their own applications to add more mobility services that can be paid for through that application. So this slide just depicts sort of the process that they have been going through. And in a little more detail, I wanted to show you this chart, which is their whole MaaS development cycle. And you can see in the lower left that they started working on this in 2014 in developing some of the partnerships with, for example, Uber and Lyft, and looking at how the services can be integrated, looking at how the payment will be integrated, and frankly, that's one of the more significant aspects of mobility as a service that is not easy to do right away, and that typically takes more time. And then looking at some pilot programs. So that's really their phase 1, which goes up through about 2021. So we're not all that far away from it. And then from there, they have a set of steps that they're taking to really become a full mobility as a service provider. And that's looking at various kinds of business models, at some point adding automated vehicles into the picture. And there's another thing I want to highlight, and I just should have put a circle around it. It says mobility behavior. And the reason why it says that, and why is that so far down on their development cycle, is we do not know how people will change their travel behavior when mobility as a service is made available. We really don't. We have a couple of case studies from Scandinavia. One of them is 5 years old now. That was the original mobility as a service system that was operated as a demonstration pilot in Gothenburg, Sweden. And now we have a full deployment in Helsinki that is very closely being evaluated, and a lot of other smaller deployments in Europe. But frankly, we still don't know how behavior is going to change. So DART has recognized that as something that they need to focus on. Let me talk for a minute about a smaller system and one that involves a little more on the suburban side. You can see this is in Dayton, Ohio. They have a fairly significant transit system. It goes out to a variety of counties. They are looking to expand their service as time goes on, and they see mobility as a service as a very, very important part of something that they should be providing to the public. So you can see the quote there, all mobility providers will delivering one unified mobility network via their MaaS platform. They are in the process of building that. As LA Metro did, they are using their new fare collection system that they are in the process of building right now. And so that's going to be significant. I also highlighted open data as one of their goals for mobility as a service, and you'll sort of see that being echoed throughout the presentation. The framework that they put together is really, kind of your typical Venn diagram these days. They will be the MaaS provider along with a technology company. Right now they're using a transit app, and transit app will be integrating a lot of these services into the app along with Masabi, which is doing the mobile fare collection. Again, on the left, I highlighted the data piece of this, how important this is as part of the overall framework that they're building. Down at the bottom, you've got the mobility service providers, and then, of course, you have the travelers on the right-hand side. So that's what their framework looks like. And then I want to wrap up the examples by talking about the rural part of this, which is quite different than the sort of urban view of mobility as a service. In Scandinavia, typically the overall goal of mobility as a service is to reduce car ownership and usage. And it's to move people more toward public transport and the other mobility services. However, when you try to apply that in a rural environment, it's not going to work the same way. And you have to envision it a little bit differently. And that's because you don't have the supply of mobility services that you do in an urban area. And so the car is actually going to be much more important when we look at this. This is a system under development in Tompkins County, New York, and it was envisioned by Dwight Mengel, who works for the Department of Social Services. He's getting more and more concerned about providing transportation to the constituents, particularly the constituents of social services. And he said, we've got to do a better job at utilizing the supply we have and providing access to those people who really need that. So he's looking at utilizing some existing services. Some of you may be familiar with One Call, One Click services which are depicted on this slide. And the way he sort of envisions mobility as a service in the county, which is very rural, it has one small urban area, Ithaca, New York, but the rest of it is quite rural, is really educating people about what their mobility choices are in that environment and being able to provide people with, for example, a monthly mobility plan that is tailored to them specifically. So let's talk a little bit about what that might look like. These are all of these services in Tompkins County that are currently available, but a lot of people are really not familiar with them. There is a public transit system, there is car sharing, there are taxis, there's the sort of 211 system for people typically that are using social services. There's a paratransit provider, etc. So that's the supply. But now, how would mobility as a service work in this environment? And really, it's what the folks did at the Department of Social Services was kind of come up with a menu of all of the mobility choices that exist in Tompkins County. And this is what it happens to look like today. So they said, you know, what's the service? How much does it cost per unit? What are the units that I'm looking at? And from that, they are able to customize a mobility plan for an individual. So here's an example, a household that has one car, 2 adults, 1 child, and it's in the Ithaca area, which is fairly easy to walk around, so it has a high walk score. Maybe for this particular family, they want access to a car share because they only have 1 car. They might want to have bus passes, some taxi service. They might utilize some bicycle services. And there might be a membership fee. This is still something that's being decided. But you can see what the cost is on an annual basis and then what it might be as a monthly payment should they decide to have a monthly subscription. This would also be available in a pay-as-you-go kind of environment if you don't want a subscription. Here's a situation out in the rural area. And here, someone might need the services of a van pool in addition to some other services. But if they offer to drive the van pool, they get some money back. And those are the negatives, the volunteer driver revenue and a van pool subsidy. So they actually get some money back. So this might be representative of what would go on in a rural area. I just want to spend a quick moment on this because I always get asked, so, you know, the Europeans are doing all these mobility as a service systems. Where does the U.S. kind of fit in that framework? And several years ago, some folks in Sweden came up with this topology, which sort of logically shows how you build mobility as a service. And you can see on this slide that we're really still kind of at the beginning. We don't have a lot of integration yet. We're starting to integrate our information, which is great. And now we're starting to move into the integration of payment, which I mentioned before is somewhat complicated. So that's kind of where that sits. And then just to give us kind of the hooks into what Joe is going to talk about is the key enablers in mobility as a service. The number one enabler is data. Can't be done without dynamic and very high quality data, because people need to know not only what their options are, but what is going to affect their trip as they're making their trip. So I want to bring that up. And then also, I want to remind us, again, this is not all about public transport. It's also about traffic management, because if part of the trip that the traveler is taking is on a roadway, they need to understand, how that roadway is flowing. And we really need to integrate that into mobility as a service a little bit better than perhaps we've done in the past. And then the last thing that I want to leave you with is a question about realizing that if I take a trip from point A to point B, and Joe takes a trip from the same point A to the same point B, we might actually choose to use different modes for our trip based on what our goals and objectives are for that particular trip. I may decide to take transit. Joe might decide to drive to a park and ride and maybe use transit, maybe use another service when he gets off of transit. So I've been discussing this at the international level for quite a few years now. And there has to be at some point in the future a balance of the goals and objectives of individual travelers, the goals and objectives of the cities and regions that are providing the mobility as a service, because those perhaps are maybe environmental goals or whatever. So they want the travelers to make better choices that help them meet their environmental goals. And then, of course, we have the private sector, which is both providing mobility services, presumably within the city and regional goals, and also providing the platforms that the travelers will be using to access mobility as a service. So that really wraps up my part of the presentation, and I guess we will move on from there.
Carol, thank you. There are a couple questions in the chat box I just wanted to throw your way. Thomas Hill asked, why does the difference between MOD and MaaS matter? Good question.
That's an awesome question. You know what? In the future, I don't think it's going to matter. I think now it matters because mobility on demand is a much broader concept, and it can be approached. You don't have to have mobility as a service to make it work. But I think your question is right on, because if we're talking about this maybe 5 years from now, there won't be any difference.
All right, thank you. Also, I guess there's a comment in the chat box by Jenny who asked if anyone's aware of the status of FTA's MOD sandbox evaluations, and have any evaluations been published yet? Would you happen to know?
There are some. I can provide to the I-95 folks a link. Most of the evaluations are still underway, and another piece of it is you all may be aware that the Integrated Mobility Innovation Demonstration, the RFP, or what they call Notice of an Opportunity for Funding, is out, and those applications are due, I believe, August 1st. But I can also provide a link to the I-95 folks for that. But the evaluations for the first sandbox are not all complete, but there is some documentation out there already on a few of them.
Okay. Here's a good question for you. Kelly has a question about. I know they're struggling at the executives. She's at DC. The executives are frequently encountering terms, and they're asked to speak on both terms, and they're asked to speak on one or the other, and so they rely on staff to provide a simple, clear distinction. So explaining, do you have a simple, clear distinction? One word, one sentence, not one word, one sentence you could provide to Kelly if you had to?
Yeah, I think mobility as a service is a tool to help you achieve mobility on demand.
Okay.
That would be my one sentence.
And the last question in the chat box before we move on to Joe. Emma's got a question. She's asking if a customized approach is feasible beyond the local level, because it sounds great, but she's wondering about the revenue. Any thoughts?
That's another really good one, because since we don't have a lot of experience yet with this, we don't know how feasible it's going to be financially to have the sort of personalization that I just showed you in the rural example. And one of the mobility as a service companies in Europe that started deploying, they have actually changed their subscription packages based on what they are learning. But there's another aspect of this, and I don't want to sweep it under the table because we need to be aware of it. A number of the private mobility as a service providers, like this one company, there are several of them, but this one company in particular in Finland, they are supported by venture capital. And it brings to bear the same questions that people ask as Uber and Lyft became publicly traded companies and the venture capital goes away. We're still all kind of sitting at the edge of our seats to see if these mobility as a service, subscription packages will lead to enough revenue to keep this as a feasible tool to use for mobility on demand. So the jury's out.
All righty. One last question, and then we're going to go to Joe. Mohan asked, what's the European example that you just mentioned? Can you speak to that?
Sure. The name of the company, and this is not to slight any other companies, because there are a lot of them, it's actually called MaaS Global is the name of the company. Their system is called WHIM, W-H-I-M, a very clever name for an app, so you can travel on a whim. And if you Google that, you will find their deployment that they have done in Helsinki, which was their first big one. And they're doing a couple of other ones. There's one in the UK. There's one in Antwerp, Belgium. There may be one other one. And they just kind of jumped out ahead of some of the other private companies. But you can look that up.
Thank you. Great. Carol, thank you.
Sure.
For those on the web, please continue. If you have questions and you're thinking, put them in the chat box. Carol and I will monitor them as we go. I'll move on. But next, I'd like to move to Joe Castiglione. He's from the San Francisco County Transportation Authority. He's going to talk to us about TNCs and data. So, Joe, take it away.
Oh, thanks so much, Denise. I'm really pleased to have an opportunity to talk to this group today. And my presentation, as you just said, is on TNCs and data. And this has been a really key issue that we've been looking at here in San Francisco for the last couple of years. Just briefly, what I'd like to cover in this presentation is to first tell you a little bit about the organization I work for, the San Francisco County Transportation Authority, to talk about the questions that we really want to answer, because whenever we talk about data, I think it's really important for everybody to understand that we don't collect data just for the sake of collecting data. Collecting data can be expensive, storing it can be expensive, accessing it, working with it can be expensive. So we really want to be very intentional about what data we get, and so we want to have it specifically oriented to answering certain questions. Talk to you about our experience trying to get data about TNCs to answer the questions that we had, share with you some of our findings, and then maybe offer some thoughts on what I think agencies should do to acquire and manage data. So first, just a little bit of background on the San Francisco County Transportation Authority. We're actually a special purpose government agency set up almost 30 years ago to administer funds from a half-cent sales tax that had an expenditure plan around a set of transportation infrastructure and program improvements. We also have taken on a bunch of other roles subsequently. One of those, and that has really been core to our work around TNCs, is that we're the congestion management agency for San Francisco County. And in that capacity, we're really required by state law to monitor congestion at least every other year, to adopt plans for mitigating traffic congestion if it reaches a deficiency level. We also program and allocate federal, state, and local funds. We prepare this kind of congestion management program every other year along with our data monitoring. And we also actually have an eye towards the future. We're responsible for developing San Francisco County's long-range transportation plan. And so, it's in both support of our role as the congestion management agency, as well as our responsibility to develop a long-range transportation plan that we're really keenly interested in this question of TNCs. What you can see on the right-hand side of this slide, we have an interactive visualization. One important thing that we do, I think, is we put all of our data, or as much of data as we can, we try and make it engaging and available to the public or anybody. And in fact, this shows at the top our level of service in 2009, where greens generally represent good, yellows are kind of in between, and reds and oranges are bad. At the lower image, you can see in 2017, so just 8 years later, that whole kind of northeastern core of San Francisco transitioned from mostly yellow, mostly about C, to significantly or majority red and orange, so levels of service D, E, F. So there really was a significant degradation or increase in congestion, degradation of speeds in that very short time frame. So, why is San Francisco interested in getting data? Well, it's because, as I said, we have a lot of questions. And actually, with respect to TNCs in general, what we had observed in our congestion management program monitoring was that, as I said, speeds had really declined quite precipitously in this relatively short time period. And at the same time, people were seeing a lot of TNCs on San Francisco streets. And in fact, I think when TNCs first showed up, in fact, both companies were started, both of the big companies, Lyft and Uber, were started here in San Francisco. I think people felt like it was really just an unmitigated good. They had really, fast access to essentially a low-cost taxi with a tremendous amount of ease of calling and paying and all that sort of stuff. 4 or 5 years in, so now we're talking around 2015, 2016, when congestion had empirically and observably gotten much worse, people were saying, well, congestion's gotten a lot worse. There's a lot of TNCs. Is there a relationship between these? And so we really wanted to just get some basic information about, how many TNCs are out there. And in fact, TNCs are required to report a whole bunch of data to the state, to the California Public Utilities Commission. But we didn't have access to that data, and I think I'll talk about that a little bit later. But we just wanted to answer some basic questions, like how many of them are out there and what are the effects? And this is really important because, as I said, there was a lot of change over a short period of time. And when we're in periods of kind of disruption or rapid change, data is really more important than ever. So I have this classic S curve. This is, economists use this all the time. What you see is on the left-hand side of the curve, kind of early on when technologies are just being developed, there's maybe a low amount of penetration, and it's relatively steady, kind of flat. And then you go through a period where there's rapid adoption and expansion of the market. That's the kind of steep part of the curve, and that's, there's tremendous growth happening there. And then oftentimes you reach a saturation point and it starts to flatten out. And So we were not at all aware or clear on where we were. Are we at the bottom of this curve? Are we in the middle? Are we at the top? And that has really profound implications for the kind of public policy making. And it's really important. I mean, this is one thing that we really strive to do and is core to our values and mission as an organization, is that we really want to bring meaningful, actionable data to our decision makers and analysis so that they can really make informed choices. And that data really needs to be transparent so that we can share it so others can look at it and so on. So what are some of the questions that we really wanted to answer initially? Well, many of those questions initially were just about the existing conditions. You know, how many TNCs are operating in San Francisco? How many trips are happening? TNC trips are happening. When are those trips happening? Where are those trips happening? How much VMT, or vehicle miles traveled, are they generating? Here in California and San Francisco specifically, we've been moving away from using roadway level of service to assess environmental impact of projects and more towards a VMT-based metric. So we're really interested in this question of VMT. But also looking at things like, do TNCs provide good geographic coverage across all of San Francisco's neighborhoods? The questions weren't limited to that because those kind of, as I said a moment ago, really describe your existing conditions, but there's all sorts of implications for those existing conditions. And so there's a whole bunch of other areas that we're really interested in asking or answering other questions. So like with respect to congestion, are TNCs contributing to congestion? And if so, how much? Are TNCs affecting transit ridership? So there's been a lot of discussion or rhetoric around TNCs are really complementary to transit, that they can provide first and last mile service. Is that happening, or are they really competing, like taking folks who might have otherwise gotten on a bus, but instead they're jumping in a TNC? In San Francisco, it's really critical. We have an incredibly diverse population. We really want to make sure, and diverse neighborhoods, we really want to make sure that all San Francisco residents are being treated kind of equitably. We're really interested in questions of street safety. And when I say street safety, I just don't mean people driving around in cars, but the people who are getting on and off of transit vehicles, biking, walking, etc. And then questions of policy, like what is the role of government potentially in regulating TNCs or other of those components of MaaS systems that Carol referred to. So in order to try and answer these questions, there's a whole set of different data that we really might be interested in and could really use, not just be interested in, but really need to have. And this isn't just related just to TNCs, but it's illustrative of the type of information that we're interested in. What's out there? What's our kind of basic inventory about the transportation network? How is that network performing in terms of travel speeds, travel volumes, travel time reliability, demand? When I say demand, I mean like how many trips are being taken to or from different areas by different times a day using different travel modes. Demographic information. Who's using these different modes? For what reasons? And then how do people make trade-offs between the different choices that they have available to them? We had all these questions. We're really interested in data. And something was kind of unique in San Francisco, or I should say in California, was that historically for hire vehicles had typically been regulated at the level of cities and municipalities. But around 2012, just as TNCs were starting to take off, the state legislature actually awarded the authority to regulate TNCs. And I should actually say TNCs, I should have said this at the outset, refers to transportation network companies. And that's the legal term that we use here in California for companies like Uber and Lyft. And so back around 2012, the state kind of authorized the California Public Utilities Commission, which is a statewide agency, to regulate TNCs. And actually, as part of that regulation, and technically part of the rulemaking that followed the regulation, TNCs are actually required to report incredibly detailed data to the California Public Utilities Commission, in the sense that every trip request is logged, and whether that trip is fulfilled, the time of a pickup, the time of a drop-off, relatively aggregate at a spatial level, to the zip code level, but really incredible information on fares, times, etc. So an incredibly, potentially really rich and useful data set that could support our analysis and answer a whole bunch of these questions. Unfortunately, notwithstanding our request and the request of many other public agencies here in California, the CPUC, again, the California Public Utilities Commission, wouldn't share any of that data with us because they said it was not in the public interest. And so we had to get a little bit creative because our needs for the data hadn't diminished, but the logical source for this was not going to share it with us. So how do we go about getting that data? Well, essentially the data was scraped from the APIs of Uber and Lyft. So what do I mean by scrape and what do I mean by API? When you open up your smartphone and you call up an Uber or Lyft or other TNC application and you see those little cars driving around, what your phone is actually doing is it's sending a little message to a server via this API that lives somewhere, and that server then returns to your phone information about how many vehicles are driving around. Like, I think it's typically something like the nearest 8 vehicles, and those little trajectories that you see. People often say, oh, those must be totally synthesized. Well, in fact, the information, while those visualizations may be synthesized, the information that is being returned to your phone is real information. And so and what we did was we teamed up with these computer scientists at Northeastern University, and they had some programs that essentially, for a couple hundred locations in San Francisco, every 5 seconds for about 6 weeks, at hundreds of locations across the city, they would ping the API, and that would return a stream of information to their computers. And that information is essentially telemetry data. So I'm sure you're all familiar with GPS, global positioning system data. It's all those little breadcrumbs. Sometimes we refer to these points in time and space, lat long and a timestamp. And with this rich set of data, my colleague Drew Cooper was able to kind of deduplicate and condense it down to a incredibly detailed representation of all of the TNC trips that are happening in San Francisco. And in fact, on the image you see on the left is kind of a visualization of where all these trips are happening. For those of you who are familiar with San Francisco, that kind of hot spot in the northeast quadrant, that's the traditional downtown core, financial district, Chinatown, North Beach, and the really burgeoning South of Market area, which is growing like crazy. So we have this incredibly rich data set. But there were some limitations. These trips weren't directly observed. I should note that nothing was, no trips were requested, no drivers were, called as a result of this. It was completely passive. And I should say we also consulted extensively with our general counsel beforehand to make sure that there was nothing that we were doing that wasn't on the up and up. It also didn't tell us, it told us where all these vehicles were when they're driving around and where people are being, kind of essentially drivers are accepting rides and then dropping folks off. But it didn't tell us like why people are traveling in a TNC, how many people were in it. That's another really critical thing, is that people talk about they may actually be reducing congestion by virtue of the fact there's a lot more people in it, in them, how much people paid, and the traveler attributes, et cetera. With this data, we just kind of did a profile. We called TNCs today, and what we found was on a typical weekday, there's about 170,000 of these TNC trips starting and ending just in San Francisco. So it doesn't represent folks going back and forth to our, SFOs, our airport, or other counties. Just to give you a sense of the magnitude, that's about 15% of intra-SF vehicle trips. And we also have similar data set for taxis because we do regulate taxis. And it's about on the street at any given time is typically between 12 and 15 times as many TNCs on the street at any given time of day as there are taxis. And of course, this was not quite 2 years ago, so I'm sure that has grown since then. What this means in terms of, VMT, as I said, is the key metric of over, well over 500,000 vehicle miles of travel on a typical weekday, and that really represents a floor estimate. And then you can see some other statistics. For example, the average trip, whether you're in a TNC or a taxi within San Francisco, is about 2.5 miles. But the amount of deadhead VMT, which is when they're driving around without a passenger, which is really just adding to congestion, right? Because they're not serving any passengers, is actually lower in TNCs, most likely just because of the size of the they can get to travelers faster. Well, where or when are these trips happening? They're primarily happening, what we found is that they're really primarily happening in the most congested parts of the city, that northeast quadrant, and they're primarily happening at the most congested times of day. The image you see on the right, you can go to, there's a URL in the upper right-hand corner called tncstoday.sfcta.org. I'd encourage you to check it out. It's an interactive visualization, and you can really explore how trips happen in San Francisco across all days of week, pickups and drop-offs, and all hours of the day. There are some other interesting patterns. You can see in the lower left, this is a chart of the black line represents the TNC trips by day of week across an entire week. And actually, you can see that the trips increase generally throughout the week. There's a clear diurnal, AM, PM peak pattern during the weekdays. On Fridays and Saturdays, you can see, an even later kind of bars closing peak, we call it. And then on Sunday, there's a drop-off in trips. People were really fascinated by this. They were like, wow, that's incredible. So you've shown that they're in the most congested parts of the city at the most congested times of day, but are they increasing congestion or are they decreasing congestion? And there's been all sorts of theories about how TNCs might decrease congestion. It could be, as I said, through increased vehicle occupancy, people using these pooled services, sharing rides. They might have been driving by themselves before. Now they're sharing a ride. It could be due to the fact that they're using transit more by virtue of having more easy first and last mile access to transit, so kind of really complementing transit. It could be that by virtue of the fact that they now have this, relatively affordable or less than a taxi kind of auto option available to them, that allows some people to kind of shed having two cars. Maybe they just have one car now and they hail a TNC. So that might also then have secondary impacts on their travel behavior. They might be walking more or biking more. Conversely, they might actually be increasing congestion rather. As I said a few moments ago, through deadheading, when vehicles drive around without a passenger, they're just purely adding to congestion because they're not serving or helping move anybody. It could be that they're actually inducing a mode shift away from transit because now there is this new option that's more, convenient or relatively inexpensive or more comfortable, say, than taking a long walk or a long bike ride. And it could be also that they are disrupting traffic. So at least in San Francisco and other urbanized areas, I think people observe this. People get in and out of vehicles. They'll maybe pull over to the side, maybe half pull over to the side of the road to access the curb. Cars maybe queue up behind them. That all potentially could add to congestion. But in San Francisco, there are a lot of other reasons, and elsewhere too, why we may be seeing changes in congestion, right? There could be that between this period of our analysis, which was 2010 to 2016, there were some network changes. We put in what we call red carpet lanes, kind of transit-only lanes on certain key corridors. We increased capacity. We rebuilt essentially a freeway segment that connects the Golden Gate Bridge with downtown. So maybe those network changes are contributing to congestion. There was tremendous population change. We added about 80,000 new residents. That was about 10% increase in our population or more just in 6 years. Most significantly, however, we had a massive boom in in employment. Our employment grew by over 150,000, workers, something from about 570,000 to over 700,000 jobs in the city in this very short 6-year time frame. All of these things may be contributing to congestion as well. People coming in and out of the city or commuting within the city or just residents making trips around. And there may be other causes as well. For example, rise of delivery services. That could be adding additional vehicle trips. Well, what did we find? Well, when we actually did this analysis, very detailed analysis, we used, I should just say by way of background, all of the TNC data that we had, a model that allowed us to capture the effects of adding population and adding employment, and INRIX data, so observed data at thousands of links at different times of day across San Francisco. We actually found, as measured by 3 different key measures of congestion, delay, VMT, and speeds, that TNCs accounted for about half the worsening congestion in San Francisco between 2010 and 2016. And it was about a quarter for the population growth, about a quarter for employment growth, and the network changes had a very limited effect on congestion. But one thing I like to say is that these changes, these impacts, these effects are not spread equally across all parts of the city or across all times of day. So here's an illustration. We did our analysis for 5 different time periods. And you can see, there were certain time periods where, for the most part, speeds went down by about 3 miles per hour. during this 6-year time period. During the middle, so you see from the early AM is on the far left, and then the middle 3 are the AM peak, our midday, and our PM peak. And they just typically went down about 3 miles per hour during that period, and about half of it, again, was due to TNCs. But if you look in the evening time period, which had historically been less congested, we actually had a really profound drop in speed. So over 4 miles per hour, almost 4.5 miles per hour drop in average speed in San Francisco streets during the evening time period. And 75% of that increase in congestion or decrease in speeds we attribute to TNCs. Lots of other questions, though. Like another question people ask us all the time is, what are the effects on transit ridership? So actually, we have a study we're doing right now. The results aren't quite out yet, but there was a previous study that was done just this past year. This was published at the Transportation Research Board's annual meeting back in January, where a researcher actually went and got all this national transit database data from a whole bunch of regions across the country. And you can actually see that with this chart is showing the kind of relative change in ridership per vehicle revenue mile, going back all the way to 2002. And you can see up through about 2012, there's a generally like modest but slight upward growth in this. And just around 2012, 2013, which is about the time that TNCs really started to become more widely available, not just in San Francisco, but in many other cities, we really see this measure go down. So we start to see a real drop-off in ridership. So this really suggests, and the longer TNCs were in any given regional market, the more precipitous that drop in transit ridership had been. Well, what about equity? What can we say about equity? Well, one of the things, as I said, our original TNC data didn't tell us anything about who's actually using them. We've actually now done a larger scale app-based travel diary survey where about 5,000 or 6,000 people in San Francisco and in the Bay Area carried around an app, installed an app on their phone. We paid them an incentive to do so and recruited them randomly. And it followed them around for about a week. We got about 150,000 trips from that, as well as all sorts of really interesting information about demographics. This compares some of our results to Sacramento results, which did a similar survey. They actually found, interestingly, in Sacramento, that some of the highest, and I say highest, if you look at these are mode shares for TNCs, about 1% or a little bit less, 0.75% overall in Sacramento. But you can actually see that usage is a little bit higher among some of the lower income segments, which are on the left-hand side of the chart. Conversely, in San Francisco, which is on the right hand, we actually see that TNC usage increases with income. But there is so much we really don't know. And you saw this slide earlier with from Carol's presentation. We really don't understand the implications of TNCs for MaaS and MOD because we have been struggling to get data. We're now seeing more and more data, but we also don't know what the future holds either for MaaS, how MaaS and MOD evolve over time, but how the TNC business model itself evolves over time and whether it's sustainable. There are other things that we don't understand. Carol referred to, like, it's not just about moving people, it's also about moving things, moving goods. And so we're really interested in looking at, and we don't know, we have very little data on the effects of things like online shopping, although our survey did reveal to us that on any given person day, about 20% of person days in the Bay Area, somebody gets a package. So basically, more than once a week, the average household gets at least one package delivered to them. And of course, again, there are all these other questions about what the effects of those deliveries are. We have had this really profound, challenge with data. Some cities have had more, and some cities and regions and states have had less success in getting data. In New York, TNCs are actually regulated by the Taxi and Limousine Commission. They get tremendously rich data, including, highly detailed spatial data. In Seattle, they're also getting some more detailed information, not as detailed as is available in New York City, but still reasonable information at a relatively disaggregate spatial level, all the way down to zip codes and information on the total number of rides and so on, as well as the key thing that we're interested in, as well as Seattle, which is the provision of accessible vehicles to San Francisco residents. Boston actually does get some data. There had been some partnerships with Boston that didn't seem like they quite worked out, but the state actually does get a bunch of data. They put out, I think it's an annual report now. The data It's extremely useful from the perspective that it can tell you something about the trends, which is really important if you think back to that first slide, like where are we on the growth curve? But it's typically at a city level, so it's really hard to say much of anything about what may be happening at the local level when you have data at a city level. So for example, in our analysis of the effects of TNCs on congestion, we actually not only were able to break it down in terms of how much of it was due to, how much of that increase it was due to, population growth versus job growth versus TNCs, but even within the segment of the increase in congestion that we attribute to TNCs, how much is due to carrying around passengers, kind of with, in-service VMT, how much is due to just deadheading, and how much is due to that pickup and drop-off activity. And about 20% of the total amount of delay attributable to TNCs was attributable to the pickup and drop-off information. You can only make those kinds of inferences and conclusions with really detailed data on where those pickups and drop-offs are happening, so that you can understand how much did the change in the speeds on this street relate to all of these other components. One of the things that has been really profoundly gratifying about participating in this work is that data really and analysis really can help influence and affect policy. So for instance, here in San Francisco, voters are going to have the opportunity, I believe, this November to vote on whether, a small 3.5% tax on TNC trip fares should be charged. That was an outcome of the work that our agency did. Revealing the size of the TNC market has actually prompted both regional and local agencies that have travel demand forecasting models, maybe that they use for preparing their regional transportation plan, maybe that they use for looking at local traffic impacts, to recognize that we need to say something about TNCs because this is a big market. Here in San Francisco, we have really, quite stringent rules about development, and we're starting to see that land use development and transportation impacts are subject to more rigorous analysis as a result of the work that we've done. And now we're even, about 9 years ago, we put out a study that was looking at congestion pricing. And now because of this, tremendous increase in congestion, we're looking again at congestion pricing, not specifically to target TNCs, but to say, we have to get a handle on this. There's all this change, and there's going to be more change to come. So how are we going to manage this in the future? So how should cities get data? This is really tricky. The first thing is that I think one of the lessons learned from California is that there needs to be a connection between the data that is collected and the data that is available to public agencies and where the impacts are occurring. So here in San Francisco, as you've seen in the information that I've shared with you, there's been a really tremendous impact of TNCs on congestion, we believe, and a tremendous number of TNC, simply number of trips that are occurring. In Sacramento, it's not as big a deal. That's where our state capital is. So, we're in this awkward position where we have really important questions and are experiencing really important effects from this proliferation of TNCs, but the state won't give us any of that data. So connecting where the impacts are occurring is important. Requiring data reporting is important. One-offs that are around pilots that aren't consistent, that aren't over time, longitudinally, so we can look at trends, not useful. We have to have systematic, ongoing data reporting and require it. The other thing is that we really do, as I said, the CPUC for us has a lot of data, but they won't share it with us. So developing kind of interagency data sharing guidelines that address any concerns around privacy or dissemination, I think is really key. What you see on the image here on the left is a screenshot from the app that we use, developed by a company called Resource Systems Group, to collect that travel diary data. And it does collect quite detailed information about TNC trips, including things like, hey, it looks like you took a TNC trip for this. If a TNC weren't available, would you have made this trip? And if you would have made the trip anyway, what mode would you use? So we can get at things like induced travel and mode shift. How should we manage this data? As I've tried to illustrate in this, getting really aggregate data, citywide level data, or no data at all is really not useful. We can't say anything about first last mile unless we can really understand whether that trip started or ended at a transit station. We can't say too much about congestion impacts because congestion varies wildly in time and space, or about other transit operational impacts, or about how we should manage the curve. It's all really difficult if we only get this big, blurry aggregate numbers. That said, we also have to really recognize that there are 100% legitimate concerns about the need to ensure and protect potentially personally identifiable information. But I think, there's a lot of instances where we have, I think of our own, in the Bay Area, we call it Clipper Card, which, contains lots of information on individual travel patterns, or transponders, which contain information about traveler patterns, where, there's a lot of precedent in the public sector where we actually do have, comparable types of data, and we've been very successful at ensuring that that information isn't compromised in any way. And then, finally, transparency and accountability are key. Everything that we do, we really try and make the data available in a way that no personally identifiable information is revealed, because without transparency, without the ability for others to look at the data, to come to their own conclusions, to add data to it that can help inform and answer more questions, it's really not as robust or reliable or as trustworthy. So where do we go from here? I think any region, any state, any city really needs to identify, as I said at the outset, what are the key kind of policy questions that you're trying to answer, and then getting data that speaks to those. One way to do that is to require data reporting, ideally through a common standard. I'm not sure if any of you have heard of the mobility data specification. It was developed by City of Los Angeles' Department of Transportation. They're using it with some of their new kind of mobility, the electric scooters, that sort of stuff. Our partners, or our sister agency here in San Francisco, the San Francisco MTA, is actually using a version of the MDS for all of the new mobility folks that they are regulating, not TNCs, but electric scooters, electric bikes, et cetera. Having explicit privacy protection and data sharing standards, I think, is really key, and really encouraging multi-jurisdictional, multi-agency collaborations. Here in California, there's a very effective consortium of the 4 big MPOs, which are LA, the San Francisco Bay Area, San Diego, and Sacramento, where they pool knowledge, they pool resources. That's really key. It's not that every city, in fact, there are cities that are more comparable. I think of like a city like Boston or a city like Washington, D.C., probably very comparable, and lessons that can be learned here in San Francisco are probably relatively transferable to some of those cities, but maybe not other cities. So, maybe a city like Worcester, Mass, or New Haven, Connecticut isn't the same. So, we have to, but we can still benefit from sharing information and sharing experiences. So with that, I'm going to leave this slide up here. One of the things I would just say, it's a little bit of plug, not so much on MaaS or TNCs, but we really try and engage the public through interactive data visualizations and very easy to read, friendly, public-facing reports. TNCs and congestion was our most recent. You can find some links there. And each of these has a website where you can go to and just literally go and play and explore the data. TNCs today was our profile. And then later this year, we're going to be coming out with a couple more reports, one that looks at the effects of TNCs on transit ridership, specifically here in San Francisco, and another provides a profile from an equity perspective of who TNC users are. So with that, I'm happy to take any questions.
Joe, thank you. In the chat box, there are quite a few questions. If I could just go through a couple of them with you. Nathan
Sure.
Webster asked if you have a before and after count of total VMTs, meaning taxis and TMCs, before it'd be considered as early 2010s, before TNCs were available.
That's right.
Note that personal vehicle VMTs may now be lower because of TNCs. So do you have a before and after count? That I think is what Nathan's asking.
Well, so the way that we did this analysis, so for we have TNC, we had taxi data from before and after. That's because SFMTA regulates taxis. The TNCs were not on the streets in 2010, so we basically they're kind of zero in 2010. By 2016, that's where we got all the information that was the Northeastern University computer scientists shared with us. So that's where we got that from. With respect to estimating the effects and the increases in VMT due to all those other factors, the population growth, the employment growth, those come out of that very detailed activity-based model that we use here in San Francisco, and that we have used extensively for 20 years, and that's all validated to base year counts and that sort of stuff.
So Nathan, if that did not answer your question, put more information in the chat box, or we can follow up afterwards. Thank you, Joe. Jenny has a question about what TRB study was the transit ridership impact graphic from?
Sure. Let me roll back to that. I believe, Denise, that you're going to be sharing the slide. There's a credit below it.
Yeah.
It was by researchers. My eyesight is failing right now. It was Dr. Greg Earhart, a guy named Grayler, and Alex Mucci, called "Understanding the Recent Ridership Decline in Major U.S. Cities: Service Cuts or Emerging Modes."
Okay. And know, Jenny, that we will have these presentations on our website, so you can get access to them there as well. Next question for you. Thomas Hill asked if you could explain the methodology you used to determine the percent impact of TNCs to travel time increases.
Yeah, so sure. Well, I'll try and briefly summarize it. It is technical. You can find references in the reports, the TNCs and congestion report here, where we go into some more detail. And in addition, there was a very academic paper that laid out all of the kind of methodological and data nuances. It was actually really just recently published about a month ago in the journal Science Advances, which is a peer-reviewed journal. But in a nutshell, what we do is there's three major sources of data that we have. With respect to the observed data, we have observed data on speeds. That comes from INRIX, a big data provider. And as I said, that's available for about, I want to say it was 1,400 what they call traffic messaging channels here in San Francisco, basically covering the entire city. You can see the level of coverage in the slide that I have above on the upper right for 5 different times a day. And with that, we're actually able to calculate what we call a kind of an imputed volume associated with that using very traditional volume delay curves. We then use our TNC information, which tells us how many of the vehicles how many TNC vehicles are on streets, either carrying passengers or empty. And for each of the increments of the population and employment growth, we used our travel demand model run in each of these years. And I should also note, when we run the model, it's validated first to the base year. And then by virtue of the fact that we're looking back in time, there's no forecast at all. We use observed data on where employment was, where population was, and that actually gives us the estimate of the delta in the, what we'll call private travel. And I should also note that this model does incorporate a commercial vehicle and freight model. So if there was new activity due to new freight and commercial vehicle movements due to employment growth, for example, or population growth, that actually gets counted as well.
Great. So Thomas, hopefully that explains what your question. If not, please give me a shout in the chat box. All right, Joe, another one.
Yeah, and I should also, sure, and
I
should also say, if anyone wants to reach out to me directly, you can find the resources here, but I'm also more than happy to take any questions, offline. It is,
right.
I think it's a really compelling, but also it's a complicated story to try and tell, and it may not be enough time in the course of this webinar to cover all those questions. So I hope folks won't hesitate to reach out to me. Absolutely,
that's awesome. Here's another question, Tom. Has the data that you looked at identified any transit? I think it's deserts, if that's correct. And has that allowed you to make any policy decisions for new services?
That's a great question. I mean, I should say at the outset that San Francisco actually has a relatively robust transit system, both local and regional. If you were to pull up a map of San Francisco or a transit map from our partner agencies, there is extensive coverage across the entire city. That's not to say there aren't places that are better covered and worse covered. It hasn't been part of our charge as this research, as part of this research, to identify where transit service specifically needs to be improved. But I will observe, and as I said, we'll have a report that goes into a deeper dive on kind of whether TNCs have had an effect on transit ridership, and if so, where and when that effect has been, either up or down. But I would note that, here in San Francisco, typically for decades, transit ridership very much tracked population and employment growth. And it was about 2010, 2011 that stopped happening. So when you add 220, 230,000 new workers and people, those people they're moving around the city, they're shopping, they're going to their jobs. You would expect to see a significant increase in transit ridership. Instead, our transit ridership on our local service, on Muni Metro and the Muni local buses, has essentially been flat, which is very, very surprising.
All right, Joe, 2 more questions in the time we've got left. Ginny has another question. She asked if there are any indications of how TNCs for both people and goods transport may be impacting state or interstate routes, like I-95.
You know, that's a great question.
Mm-hmm.
And I don't think our analysis can help understand that. Now we do, you know, we did include, there were freeway segments that were included, but only those within San Francisco. So I can't really, nothing that we have done so far would allow me to kind of offer any insights into that, other than to say it highlights the need to have data to understand it. Because if you did have information, if you did have data on that, there are other sources like INRIC that you can look at the relationship, and of course your own HPMS or whatever counts your state DOTs may be doing or collecting, where you could say, wow, we actually are seeing these changes, and you could try to answer the question in the same way that we have in this more little sandboxy version in San Francisco.
Sure. All right, and our final question, I think it comes from Mohan. He's wondering if the site, I guess it's the California Utilities Commission, is the data that you're showing, is the site populated by the data from the Utility Commission?
We've gotten no data.
No data.
Okay. That's why we had to kind of go through this unusual way of trying to get data, because they wouldn't share it with us.
Yeah. All righty. All right. That's it in the chat box. I think that at the moment this is the question period, and no questions remaining. Just in a quick wrap up, I guess I want to thank you all for being on the call. Please feel free to reach out to me or to any of our speakers. On the screen right now, Carol and Joe both have their email addresses for further information. We hope you enjoyed it and learned a lot, and as I think it's got a long way to go, I think we're just hitting the tip of the iceberg with this topic. Carol and Joe, thank you both for taking the time to put together the slide presentations and to spend the time with our members. We really appreciate it. And with that,
you're quite welcome.
You're welcome. With that, I think we'll say good afternoon to everybody and hope you enjoy the rest of the day. Bye-bye.